Graphs and sessions. TensorFlow Computational Graph. The TensorFlow Computational Graph is a fundamental concept that forms the backbone of TensorFlow's execution model. Understanding how TensorFlow constructs and executes computational graphs is crucial for building and training machine learning models effectively. Let's dive deeper into the TensorFlow Computational Graph. What is a computational graph? By definition, a computational graph is a directed graph that represents a series of mathematical operations, which are called nodes, and the flow of data, which are called tensors, between each other. Now, what are nodes? Nodes in graph represent operations, ops, that perform computations on tensors. There is edges. What are edges? Edges in the graph represent tensors flowing between operations, carrying the output of one operation to the input of another. Now, how do you build a computational graph? First, define operations. Start by defining the operations you want to perform in your model, such as a matrix multiplication, activation functions, loss functions, which we'll probably look in a little later. Then create tensors. Creating tensors to hold the input data, model parameters if any, and intermediate results of these computations. Connect operations. Connect the operations together by specifying the flow of data between them, forming a graph structure. Here is an example. You import TensorFlow as TF, define the operations tf.Constant 1, 2, 3, 4, be tf.Constant 5, 6, 7, 8, and then we do a matrix multiplication by calling the matmul AB, and then print the computational graph by printing tf.compat v1.get underscore default underscore graph as graph definition. Now, visualizing the computational graph is the next step. You can use TensorBoard. TensorBoard provides a tool called TensorFlow provides a tool called the TensorBoard for visualizing computational graphs. You can log the graph and view it in TensorBoard to understand the model structure and flow of data. tf.Summary.FileWriter. Use the tf.Summary.FileWriter class to write the graph to a log directory, which can then be visualized in TensorBoard. Here is an example. We create a go through session tf.compat v1 session as sesh writer equal tf.summary.filewriter log directory logs, the name of the directory, graph equal to sesh.graph, and then writer.close, and it will have your logs written in the logs folder. You'll have that particular graph, computational graph. Now, executing the computational graph. Session execution. In TensorFlow, computations are performed within a tf.Session context. When you run a session, TensorFlow executes the operations in the computational graph and computes the output sensors. Example is here with tf.compat.v1.session as sesh result equal to sesh.run of c print result. This will give you the result. Now, benefits of computational graphs include optimization. TensorFlow can optimize the computational graph for performance, memory usage, and distributed execution. Portability. Once defined, the computational graph can be saved and loaded for later use, making it portable across different environments. Debugging. Visualizing the computational graph helps in debugging and understanding the flow of data through the model. The TensorFlow computational graph is a powerful abstraction for defining and executing machine learning models. By understanding how to build, visualize, and execute computational graphs, you gain insight into the structure and behavior of your models, enabling efficient development and debugging. TensorFlow's computational graph execution model provides flexibility, performance optimization, and scalability for building complex machine learning systems.